Expertise and expert thinking. Expertise is an advanced state of thinking and behavior. Experts are not only highly skilled in a given domain, they are also often known explicitly for their expertise. They may be defined by it, and quite often they make a living at it. Expertise is something that many people can obtain, but not everyone will. Expertise is related to skill and practice, but expertise goes beyond merely being skilled. An expert is someone who is extremely skilled, and not everyone is extremely skilled. Not everyone can be an expert. Experts are rare. You are probably very skilled at some things without even realizing it. You are, relatively speaking, probably highly skilled in terms of reading in your native language. You spend many years learning to read. You practice and are frequently tested and assessed. By secondary school and university, you can read quickly and extract the details from a passage of text. Of course, it does not really feel like expertise because it is something you do without much thought or consideration. Most people you know probably have reading skills that are comparable, and so your individual skill with reading does not stand out or seem remarkable. That is, you are highly skilled at reading in your native language, but this skill does not constitute expertise. Unless you have an English degree, then you're probably pretty freaking good at it. However, there may be other areas in which you might be an expert. Perhaps you have mastered and excelled at playing an instrument or have competed at an elite level in a sport. If so, you may be an expert in these fields, and if you are using this text in conjunction with a course that is being taught at a college or university, the professor who is teaching the class might be considered an expert in their field of study. In general, however, most of us are not experts. We may have attained mastery in some areas, but have probably not achieved the more elite level of expertise. This chapter discusses what an expert is, what expertise is, and how expertise develops. The second half of the chapter discusses the effects of expertise on cognition. Objectives. On completing this chapter, you should be able to achieve the following: describe and define what it means to be an expert, understand how expertise develops, and be able to discuss the evidence for and against the role of deliberate practice in expertise. Explain the effects of expertise on perception, cognition, playing chess, and making decisions. Be able to recognize expertise in different domains and professions, especially in medicine. Defining expertise. What is expertise? K. Anders Ericsson is an expert on experts. His work on deliberate practice will be discussed later in this chapter. In a recent overview of expertise, he provided the following definition of how one might distinguish real expertise from skilled, competent performance. Real expertise must pass 3 tests. First, it must lead to performance that is consistently superior to that of the expert's peers. Second, real expertise produces concrete results. Brain surgeons, for example, not only must be skillful with their scalpels, but also must have successful outcomes with their patients. A chess player must be able to win matches in tournaments. Finally, true expertise can be replicated and measured in the lab. Ericsson specifies 3 aspects of true expertise: superior performance, concrete results, and replicable performance. A good piano accompanist may be able to produce consistently good performances, but may not be superior in their field. Conversely, someone who has achieved a high honor once and then faded may also not be a true expert. All experts are high performers, but not all high performers can be considered experts in their fields. Ericsson's definition focuses on expert output. Thus, one good definition of an expert is someone who is able to produce superior performance, achieve concrete results, and is able to replicate that performance in a variety of circumstances. Experts are highly trained. An expert is someone who has studied and practiced in a specific domain until they have received a recognizable status in their field. Medical experts are a great example. In the USA and Canada, for example, an attending physician would be an expert in her area of specialization because they have attended medical school for several years, put in several years as an intern, a resident, and possibly in a fellowship after that. Attending physicians, work in a hospital or clinic, admit patients, and supervise other medical residents. By the time they have taken up a position as an attending physician at a hospital, they are likely to have accumulated at least a decade of extensive training and clinical experience. As a result, they are known in the field as an expert. People come to them for expert opinion. They are able to train others in their field of expertise. Defining experts in terms of the amount of training they have received and the degree to which they have accumulated dedicated practice in their field is a fundamental definition of expertise. Experts think like experts. A third way to define expertise is in terms of how an expert's cognition and performance differs from that of novices. Experts, for example, will need less time to make a decision about something. For example, the medical expert will be able to arrive at a correct diagnosis much more quickly than a novice or an intermediate level physician. An expert may also require less information to make a decision because they will be able to fill in perceptual gaps with their extensive knowledge. Relative to novices, experts will be much better able to perceive the deep structure of a problem and will ignore irrelevant surface detail. Think of some of the problems that were discussed in Chapter 10, where the initial representation was made difficult to solve because of the way the problem was represented. An expert will be able to solve problems in their area of expertise much more effectively because access to memory will facilitate choosing the correct problem representation. To summarize, experts and expertise can be defined in at least 3 ways. The first focuses on people who produce superior performance. The second focuses on the amount and quality of training a person has. And the third focuses on how an expert thinks differently from a novice. All are important parts of the definition, and all are important in understanding expertise. Below I discuss expert training and a widely known maxim about expertise that relates to the number of hours of dedicated practice. I then discuss critiques of that maxim and alternative ways to describe expertise. Later sections will cover the differences in thinking and performance between expert and novice thinking and cognition. The role of deliberate practice. In the example above regarding medical expertise, I write that experts are highly trained. This is most certainly true for medical experts in most parts of the world. A physician might have accumulated nearly a decade of extensive training before they become an attending physician. It is difficult to know exactly how many hours of training they put in, but consider how many hours the average person works in a day. If you spend 40 hours a week working and training, that's over 2,000 hours a year. In 5 years, you will spend around 10,000 hours dedicated to doing something. Our physician probably put in far more than that on some days and probably fewer hours on other days, given the number of hours physicians spend in residency and the number of years required to specialize and achieve a full position at a hospital or clinic. By the time a physician has completed the requisite training and has spent a few years as an attending physician in a hospital seeing patients, they have more than surpassed 10,000 hours of practice. The 10,000 hour rule. The aggregate of all of this extensive practice has been described by some psychologists as the 10,000 hour rule. Broadly speaking, this maxim suggests that expertise in a field is characterized by the achievement of approximately 10,000 hours of deliberate practice. The general idea comes from research by Anders Ericsson, 1993, and the rule serves as a useful guideline for understanding how much training goes into becoming an expert. It also serves as a benchmark to distinguish experts from skilled non-experts. It is a useful rule of thumb, but is not an algorithm for expertise. That is, 10,000 hours of doing something will not necessarily make you an expert at it. Or, as Ericsson et al. Put it, the belief that a sufficient amount of experience or practice leads to maximal performance appears incorrect. 1993. In an influential paper, Ericsson and colleagues estimated that people who have achieved expertise in a given field were generally likely to have spent at least 20 hours a week over the course of 10 years dedicated to practicing and mastering the skills that are needed to become an expert. Although this may seem fairly intuitive to us now, owing to the degree to which their maxim has entered the popular lexicon, their paper was a sizable departure from the psychology of expertise at the time. Expertise was typically defined as being a result of natural ability. The role of practice was still not well understood. Practice was generally regarded as being necessary for skill acquisition, but its role in defining expertise was unclear. Erickson et al. Arrived at this conclusion by studying existing experts in diverse fields. For example, they asked university violin teachers to nominate who they thought were the best violinists in the program. Another study examined the best piano students at an elite conservatory in Berlin. Extensive interviews and protocol analyses were carried out, and the subjects were asked about when they began their training, when they practiced, how much they practiced, how they practiced, and the kind of training they received. What Erickson et al. Found was that the musicians with the highest level of achievement were those who reported that they spent close to 20 hours or more per week devoted to deliberate and focused practice on their instruments. This differed from the practice habits of those who were identified as amateurs or intermediates. Whereas by their mid-20s, experts had accumulated over 10,000 hours of practice, amateurs had accumulated only about 3,000 hours. The same pattern seemed to emerge when Erickson et al. Looked at other studies of expert performance. In short, there was a clear pattern of extensive, deliberate practice totaling or exceeding 10,000 hours that was present in expert performers, but not in players and performers who were not in the elite group. Later work by Erickson and others generalized the results and findings into many other domains. This research sought to emphasize the role of deliberate practice in the achievement of expertise, or put another way, this research argued that experts are trained and developed, and not just born. Basic talent, personality, good fortune, and luck are still very important, but this research showed that, all of these factors aside, true expertise will not develop unless the person practices deliberately and trains extensively. However, it was not the intent of Erickson and others to suggest that 10,000 hours was a magic number or a formula for expert success. This is a rule of thumb and characterizes a necessary but not sufficient condition for expertise to develop. Unfortunately, the notion that 10,000 hours of practice is required for expert-level performance has sometimes been viewed as a threshold and as an algorithm for success. Below, I discuss the shortcomings of this approach and several critiques of the deliberate practice hypothesis. Critiques of the 10,000 hours rule. The notion of the 10,000 hours rule has entered the public consciousness more recently with the publication of popular science writer Malcolm Gladwell's book Outliers, 2008. Gladwell's book covers both science and biography and profiles several well-known experts' development and rise to prominence. For example, the book discusses the lives and work of people like Bill Gates, J. Robert Oppenheimer, the Beatles, and others who have become remarkably successful. Although it touches on several themes, including the role of luck and fortune, it also discusses Erickson's work on extensive deliberate practice and refers to the 10,000-hour rule. As an example, Gladwell discusses the early working days of the Beatles, who spent many years and hours playing and performing in Hamburg, Germany, so much so that over the course of 4 years, they had accumulated about 10,000 hours by the time they returned to England. Others, such as Bill Gates and even Gladwell himself as a writer, are shown to have put in at least 10,000 hours of practice. The popularity of this book resulted in the misconception that 10,000 hours is a formula for expertise. This is an oversimplification, as Erickson's work early on indicated that practice plays a role and is not the only prerequisite. More recent meta-analytic work has challenged the 10,000 rule as well. A paper by McNamara et al., 2014, examined over 9,000 research papers about practice relating to acquiring skills. Using a meta-analytic design, they looked more carefully at 88 specific papers that had collected and recorded data about practice times. This included work with chess players, musicians, sportsmen and sportswomen, and professional expertise, and across the different studies and papers represented data from over 11,000 subjects, which is an extensive meta-analysis. Although the effects of practice were noted in all of these studies, McNamara et al. Found the contribution of deliberate practice was much lower than expected, and that it varied by domain. Figure 11.1 shows the proportional role of deliberate practice for each of 5 different areas of expertise. For games like chess, practice accounts for 26% of the variance, but for other domains, like professional expertise, the contribution is less than 1%. That is, deliberate practice was not an explanatory factor for variance in performance in professional expertise. McNamara et al. Concluded that deliberate practice is important, but is not as important as has been argued. More recent work by the same team noted that although the amount of deliberate practice predicts about 26% of the variance seen in athletes, the proportion is much lower in elite athletes. 2016. The implication is that at the elite Olympic level, everyone has trained for over 10,000 hours, and other factors such as physiology and the right coach capture more of the range. Figure 11.1 Proportion of performance accounted for by deliberate practice in several fields. Role of deliberate practice. In games, it's about 26%, music 21%, sports 18%, education 4%, professions 1%. Is the role of deliberate practice and how good of an expert someone is. In conclusion, the work of Erickson and colleagues in the early 1990s challenged a long-held notion that talent was a critical factor of expertise development. More recent work suggests that while deliberate practice is still important, it is only one of many factors that are important for expert-level performance, and it may play a negligible role for experts in some fields, especially those with a less well-defined concept of what constitutes deliberate practice. The effects of expertise on cognition. In this section, I will examine some of the many effects of expertise on cognition. This approach aims to understand how experts differ from non-experts in terms of basic cognition and thinking. Of course, it is obvious that experts will be better than novices at doing the same thing that they are experts in, but expertise may bring improvements in the cognitive processes that underlie the area of expertise. In order to understand how experts perform better than novices, it is important to look at the cognition involved in expertise. Memory. A well-known and well-studied effect of expertise on thinking is the improved memory that experts show for facts within their domain of expertise. In many ways, the modern study and understanding of expertise begins with research into experts' superior memory. In a very general sense, it should seem obvious that experts have superior memory within their own domain. For example, someone who spends considerable time following a baseball team or baseball in general will often know a lot more about players' statistics, general facts, and rules of the game than someone who does not follow baseball. If you have ever tried to have a conversation with someone who is a dedicated fan of a sports team when you are only a casual fan, it can be difficult and maybe even frustrating to keep up because they remember so many more things about the sport. 11.1 Theory in the Real World. Consider this fictional example of expertise and exceptional memory. In the Harry Potter series, when Harry first goes to pick out his wand from Ollivander, he is surprised at how quickly Ollivander remembers everything about every wand he has ever sold. And of course, he recognizes that the wand that chose Harry, remember the wand chooses the wizard, was deeply connected to the wand used by Voldemort. I remember every single wand I've ever sold, Mr. Potter. It so happens that the phoenix whose tail feather is in your wand gave another feather, just one other. It is very curious indeed that you should be destined for this wand when its brother gave you that scar. The implication is that Ollivander is an expert wand maker and seller, and he relies on his extensive memory for detail to make this observation. These are simple illustrative examples, but the relationship between expertise and memory has been investigated more systematically. The initial studies on expertise and memory were conducted with experts in chess. Chess has often been the domain of study of expertise because the game has a finite set of pieces a strict rule structure, an incredibly large configuration of positions, and, most importantly, it is possible to determine experts from novices. Expert chess players can attain a player rating, which is an objective measure of their expertise. Experts clearly play better chess than novices. That's why an expert will generally win against a novice. Early in the history of cognitive science, the group published a now famous book about how experts seem to choose smarter moves, 1965. In one study, he showed a chess position to grandmaster players and candidate master players. Candidate masters are good but not great. He asked them to think aloud as they tried to find the next best move for the white position. On average, the grandmasters found the correct move more quickly. The analysis of their think aloud protocols suggested a similar search process, so the source of their expertise must be related to the efficiency of memory recall, rather than their reasoning in general. Later work compared the results of expert chess players and novice chess players with respect to memory. For example, a study by Chase and Simon, 1973, used a very clever technique to determine the source of experts' superior performance and memory. Novice subjects and players with different ratings, all the way up to Grandmaster, were shown depictions of chessboards for a memory test. Two examples are shown in Figure 11.2. On the left-hand side of the figure, the pieces are arranged in a configuration that resembles a common positioning in the middle of the game. This is important because although there are many possible positions, there are a finite number of legal positions based on the strict movement patterns of each piece. Certain configurations have a high probability of occurring in a common game between two experienced players. In fact, experienced chess players study configurations of famous games in much the same way that experienced musicians will watch other musicians play the same piece, or experienced gymnasts will watch other gymnasts' routines and become familiar with them. In other words, highly experienced chess players know a great deal about common game configurations and are likely to know many of them from memory. Figure 11.2, an example of chess pieces in legal positions from a game and in random positions that do not correspond to any game configurations. Examples of legal and random chess positions. So the one board on the left has real game positions, and then the board on the right has random positions. So you can see that the black and white chess pieces are just interspersed randomly. The right-hand side of Figure 11.2 shows pieces on a chessboard in a random configuration. Unless you have never played chess before, a close inspection of this configuration should strike you as unnatural. For example, notice that both of the white bishops appear on black squares. In chess, the white player would have one bishop on white squares and one bishop on black squares. It is impossible to have both of your bishops on the same color square. To anyone other than a complete novice, this board configuration is meaningless. There is no way this configuration of pieces could ever appear in a real game. In other words, considering both of the configurations shown in Figure 11.2, the one on the left should have considerable meaning for expert players because it should bear a similarity to configurations they have studied and encountered in real games. The configuration on the right should not have the same effect, but to novice players, although the configuration on the right might be noticed as being illegal, it might not be that much different from the configuration on the left. Unless you have a strong repository of chess memory, the one on the left should not invoke any special memory advantage. Returning to Chase and Simon's experiment, participants, experts, and novices were shown the configurations for 10 seconds or less and were then asked to reconstruct them from memory. If you want to get an idea of how difficult this is, study one of the configurations in Figure 11.2 for 10 seconds, cover it up, and then try to draw it on a sheet of paper without looking. More than likely, unless you are a chess expert, you will fail to get most of the pieces in the right position. Not surprisingly, that's the kind of performance that novice chess players showed in the study. Interestingly, experts were able to recreate the boards quite well. Figure 11.3 shows a hypothetical example of the difference between novices and experts in terms of their ability to correctly recall and recreate the chessboard. The y-axis shows the number of pieces correctly recalled, and the x-axis shows the player rating, which is an index of expertise in this case. The solid line clearly shows that as player rating increases, so too does performance. The experts are remembering the positions correctly, but the interesting part of this study is shown by the other line on the graph. The dotted line is nearly flat, This is the performance by players when they saw one of the random configurations. Regardless of their level of expertise, participants did not perform well when they were asked to recreate a chessboard with random configurations. Experts performed no better than novice and intermediate players when random configurations were used. Figure 11.3. Performance differences between expert and novice chess players when pieces are in legal positions, solid line, or in random positions, dashed line. Okay, so this is kind of like a scatter plot, except there's two categories on the x-axis, novice on the far left to expert on the far right, and on the y-axis is pieces recalled from 0 to 30. So there's two lines. One is real game positions, so you can see as you become more and more of an expert, you can recall more and more chess pieces up to about 22.5 pieces, whereas a novice can only recall maybe 3. And when you look at the line of random positions, it's basically horizontal, which means both novices all the way up to experts can only really remember the number of pieces, maybe like 4 pieces on the chessboard that's random. The implication is clear. Expertise in chess is founded upon many years and many hours of direct experience with chess positions. This is supplemented with additional study of chess positions and game configurations. Experts have a considerable store of real, in-progress game positions that they use to play the game, and so they can recreate the game position boards, not so much by memorizing the game board they were just presented with, but rather by matching that game board to patterns stored in memory. As an analogy, consider being presented with a list of 10 familiar words to learn, along with a list of random letter strings. You will be able to recall the list of words much better than the letter strings because the words have meaning and map onto patterns stored in your lexical memory. The random letter strings have no advantage, just like the random chess pieces. Chase and Simon, 1973, argue that this is part of the basis of player expertise. Their extensive schema for these positions is how and why expert players are able to select the correct move so quickly and so efficiently. Chase and Simon argue that experts create larger chunks of chess-relevant information rather than individual pieces, which seems to be the focus of novices. Put another way, novices are focusing on individual letters, pieces, whereas experts focus on words, larger chunks. They are using knowledge-based heuristics more effectively and to their advantage. Some recent work supports this claim by examining chess expertise and tracking expert and novice eye movements, 2005. In general, experts have been found to have much larger visual spans while processing structured legal positions, but not when processing random chess positions. In addition, experts made fewer fixations overall. They fixated between related pieces rather than on individual pieces. This is consistent with the notion of structured representation and larger chunks of chess memory that may relate to internalized moves and positions from previously played and studied games. Perceptual and recognition effects. Another fundamental difference between experts and non-experts is that experts show distinct perceptual advantages over non-experts in their domain of expertise. Collectors can be experts within their domain of expertise. I have a small collection of interesting antique coins that I have found over many years. Anytime I see an old or unusual coin in circulation, I keep it in my collection. It is only an amateur collection. I do not have any idea of the value of these coins, and probably most of them are worth little more than the face value. I cannot tell the difference between one that is in good condition or bad condition, and I cannot really tell the difference between small changes that were made to a coin's face in different years of circulation. Unless I consult a guide, I am unable to notice fine distinctions between antique coins of value and those with little additional value. I am an amateur coin collector. However, consider someone who has an extensive coin collection or is a dealer. This person is likely to have spent many more hours acquiring coins, handling and scrutinizing them, and learning about the fine-grained differences between coins that have similar surface characteristics. An expert coin collector is able to determine whether or not one U.S. quarter from 1923 is worth collecting and has a greater value than another U.S. quarter from 1923. This person knows about mint markings and the composition of metals in the coins themselves. As an amateur collector, I might add both of them to my collection without care. An expert coin collector might put both of them in their collection, but might also know which one is worth more than the other and which one merits special care. I used another example like this in a chapter on the role of verbal analysis and similarity in classification, Minda and Miles 2010, but the domain was sport fishing rather than coin collecting. Consider the differences between a novice and an expert angler. A young angler first learning to fish must learn to tell the difference between fish species that are legal to catch and those which are not, or they may need to learn to tell the difference between the different species so that they can tell whether or not they have caught their limit of rainbow trout or smallmouth bass, etc. To the novice, the differences can be subtle, so they may need to use a fish identification guide that points out the critical features necessary for identification. In Ontario, where I live, the Ministry of Natural Resources publishes an annual sport fishing guide that includes this information, along with pictures, so that anglers know how to tell one fish species from another.